We saw how you can take an equation and turn it into a graph. Well, how can you do the reverse? How can you take a graph and turn it into an equation? It turns out it's actually not so bad. Let's do it this way. So given a graph like this one, we're looking to find out what number should I put in for the A and what number should I put in for the B. That's only two numbers we got to figure out. The A is typically fairly straightforward. Remember, A is the y-intercept. So take a look at your graph. Look at where this graph crosses the y-axis. That's at a height of 2. So my A is 2. Look at that. Now for the B, you can now choose literally any other point on the graph. And we're going to then work backwards and solve for the B. Now there are easier choices and harder choices. I'm going to recommend, if you can, if there is a nice intersection point, try using x equals 1. And if that doesn't work, maybe x equals 2. And if that doesn't work, maybe x equals -1, or maybe x equals -2. These tend to be easier x values to work backward from. So let's just go to our graph here, and I'm checking to see, at x equals 1, does the graph go through a nice point, a grid line intersection? So at x equals 1, that's right here. Yeah, that's at a height of 6. So 1, 6, that's an ordered pair on my graph. We can now use that information to solve for the B. Here's how it works. Don't forget, this is an x value. The 6 is a y value. So put the 1 in for the x, put the 6 in for the y. Remember that b to the first, any number to the first power, is just that same number back again. So this is really just 6 equals 2 times b. Divide by 2. That means that your b needs to be 3. So what equation do we have? Well, I know from the y-intercept that a was 2, and I know from our nice point that we picked and substituted that the b needs to be 3. Now, because this is the 21st century, I'm going to finish by checking that. Y equals 2 times 3 to the power of x. Does it go through 0, 2? Yes, it does. Does it go through 1, 6? Yes, it does. So we are in good shape. Okay, recap. Then let's do this again a couple more times. Use the graph and the y-intercept to find your a value. Once that's done, find another nice point. These tend to be the x values that are easiest to work with, and then substitute and work backward to solve. Let's go again. Now with what we have here, your practice is going to end up being most of the time multiple choice, and it's for this reason. Notice here this y-intercept. Looks to be about right there. Well, that's not on a nice grid line. So what is it? It looks to be about a height of, so let me see, that's 1, 2, so it's about halfway between 0 and 1. So it kind of looks like a is a half. And it turns out that, yeah, a is a half. But for the ones where you have to actually write out the full equation where it's not a multiple choice, I'm going to make sure it goes through nice grid lines, just so you know. All right, we've got a is 1/2. Now we need to try and find a second nice point to be able to use as an x and a y. Okay, let's see what we got. Now at x equals 1, that's the one we used last time. This is not at a nice grid point. We'd have to estimate that fraction. I don't know. I think that's going to be pretty tough. Let's go in the other direction, though. How about if we go to where x is -1? That does go through a nice grid line intersection. So this ordered pair is -1, 1. Let's now put this all together. So if a is a half, I can now put in the -1 for the x and the 1 for the y. Here's how I recommend solving this. First, let's get this, the b to the negative 1 power, by itself. Meaning, I want to multiply to get this a value moved over to the other side. Whenever you want to get rid of a fraction times that b, multiply by that same fraction flipped upside down. Every time you'll do this. So if I've got a half times this, then to remove that, multiply by 2 over 1. The reason we do that is 1 top and bottom reduces to 1. 2 top and bottom reduces to 1. All we're left with is b to the negative first. On the other side, 2 over 1 times 1, that's just 2. There we have it. Now to finish, I need you to remember what negative exponents do. Negative exponents flip things upside down. So I'm going to now take both sides of this equation and flip them and do those changes. Here's what I mean. Take the 2, which is really 2 over 1, flip it. Now you've got 1 over 2. Now for the b, when you take care of the negative exponent, flipped over, we already took care of that by flipping the 1/2. It now becomes b to the positive first. So again, I want to recap what we did. Since b upside down is 2, then b right side up is 1 over 2. That's how that works. So to finish it up then, I've got y equals 1/2 times 1/2 to the x power. The a and the b ended up being the same thing this time. Let's do a quick check on a graph. So I think this time that I had a 1/2, not 21 halves, 1/2 for the a, 1/2 for the b, goes through 0.5, goes through negative 1, 1. Those are the points I wanted my graph to go through. Okay, quick recap. We got our a from looking at the y-intercept. We used an exponent of negative 1 this time. That's why when we got to this point, change that exponent to a positive means you flip that 2 upside down. Okay, next up. I'd like you to try this one on your own and do a little pause, unpause when you're ready to check things. So first, that y-intercept. And then secondly, a nice point. That works out pretty well. All right then, here we go. So I've got y equals 3 times b to the x power. Let's then put in what we know. I know that this ordered pair is 1, 6. So 6 equals 3 times b to the first. B to the first is just b. Divide by 3. And b is 2. So my equation should be y equals 3 times 2 to the power of x. Give it a quick check. Does that go through 0, 3? Yes, it does. Does that go through 1, 6? Yes, it does. Okay, we have done good work. Give these highlights just so they're easier to spot. Bam and bam. Okay, last one here. Once again, I would like you to do a little pause and then unpause when you're ready to check. Okay, starting the same way, looking at the y-intercept. This one is a nice one. It's going to be 3. Then, so look over here. I'm looking for an intersection on the graph. Don't see one. I'm going to have to go backward. Here's one. Okay. At negative 1, 6. So what do I know? I know that a is 3. I know that when I have a 6 for the y, that happens when I had a negative 1 for the x. So to get rid of this, multiply by 3, divide by 3. So 2 is b to the negative first. Ooh, we've been there before. So change this exponent to a positive and take that 2, flip it upside down. That's what negative exponents do. They flip things upside down. That means my b is just a half. So final equation then, y equals 3 times 1/2 to the power of x. Give it a quick check. Does it go through 0, 3? Yes. Does that go through -1, 6? Yes, it does. So we're in pretty good shape. Now, if you got a little time and you want to take a look at these last two that we did, I want you to notice how the graphs look and how that showed up in the equations. What's similar and what's different? A little bit of food for thought there.